Alright, so let's look at some more solving radical equations. I was hoping you guys could help me out with a couple of these ones at the beginning. I didn't start you off as slow as I started them this morning just because I wanted a variety of examples, so there's all kinds of different ones. So, usually the first step in solving a square root or cube root problem is to what? Actually, the first step is usually try to get one by itself. So the question is, in this case, we can't really do that because both of them, you can't really get them by themselves. They have the 2 and the 1/3. You could, I guess, to get rid of the 1/3, what could you do to get rid of the 1/3 and get that one by itself?
Multiply it by 3.
Multiply it by 3. That'd be a great idea. So times 3 here, we'll cancel this out. Times 3 there will be
5, 6, or 6.
6. So now I've isolated this square root. So then the next step, the big important step, that's pretty obvious, is use the inverse operator, the square in this case, right? So we're going to square this one. If I do it to one side, I do it to the other side. Okay, so it cancels out over here totally. So we have 2x minus 2. Nice. On the left-hand side, some people are going to write this in their assignment. Some people are going to write 54 minus 2/3 x. Those are both wrong answers. Why is this wrong? I'm supposed to square the 6. It's like part of that side, so like square it. Come on. Okay, so now we've just got a linear equation. This one's a little tougher than most because it's got some fractions in it, so I'm going to go over here to kind of solve it. So here we go. I'm going to distribute that 54 first. Oh.
How did you get 50?
Yeah, 6 times 6 is 36.
I don't know. Thanks. Okay, alright, so I'm going to distribute the 36. I might need some calculator assistance. Can you guys help me? What's 36 times 9?
324.
Okay. And then, 2/3 of 36? I know 2/3 of 36. 2/3 of 36 is 24? So it's minus 24x when you distribute it through there. Okay. Fractions gone, so it should be pretty easy from here on. I'm just going to do it my way. You guys see if you can follow. Just to save us some time. I'm going to add 24. I'm going to add 2 this way. Cool? And divide by 26. I bet that doesn't come out nice. I bet it's a yucky number.
12.5384.
Is it not repeating or anything like that? It should be repeating, I would guess.
No.
No? Okay, so we'll just go 0.58. Or did you say 5.3?
5.8 or 5.3.
5.38. So we'll play 5.4. Okay, so approximately, I'll say this is approximately equal to that. Now, yesterday, if you were watching the video carefully, there was this issue called extraneous solutions, which sometimes come up. So as I told my class this morning, in high school, back in the day, my teachers throughout all of Algebra 2 and pre-calc were like, you always have to check your solutions. And I was like, dude, I'm not always going to take these numbers and plug them back in. Like, that's just way too much time. So I don't expect you guys to do that. But this is one of those times where you're going to have to be alert, like I was, because I didn't ever do that in high school. I just learned the few situations where I might have issues. Something sneaky might occur. This is one of them. If you just get one answer, though, it's probably good. Yesterday you guys saw one where there were like 2 answers. You should be a little skeptical if there's 2 answers. Maybe because of that squaring in the solution process, that's where byproducts come from in this case. There might be something that is a byproduct that doesn't work. Okay, an extraneous solution, in other words. I think we're safe since there's only one answer. We're probably good. Am I sure? No. But I'm pretty sure. Okay, so let's see if that happens on another problem today. We'll just say that's good for this one. All right, let me get this one out of the way. So you guys tell me, for an inequality like this, what should I do first? Turn it into a cube root. That's probably a good idea. Because 1/3 power is cube root. Okay, then if I'm solving it, it's already by itself. So, cube it. Alright, so cancels on the left. -2 cubed is not 8, but -8. And I just solve this guy like I did in Algebra 1. negative 32. Divide by negative 8. That's positive 4.
Greater than.
I've made a mistake because if I divide by a negative number, that's like turning my car around in inequality land. So I need to switch that up. And then, of course, since this is an inequality, there's not just one answer. In fact, 4 doesn't even work, right? This is not inclusive. If that's 0 and that's 4, what should I put at 4? Circle. And which way should I shade? Above or to the right, yeah. And then I'd really specify the solution set here by saying to infinity. Any of the things in that red, so I guess I should have made this red, are solutions to this inequality. Cool? If by chance, I don't think I gave you any like this, but if by chance on your assignment, if you ran into a problem where you got something that was not linear at this point, like if you got a parabola, we did parabolic inequalities. You need a picture. If you try to do it without a picture at that point, you'll be wrong almost always. Unless you're really good at these, and I don't think anybody's that good at these yet at this point. Okay? So you need a picture if you come upon a parabolic inequality. I don't think I gave you any in the book, but you never know. Okay? So no extraneous solutions or anything like that on this one. Let's try this next one. That one's already by itself, right? So square it to get rid of that. Alrighty. So we're going to say it cancels nicely on the right-hand side. On the left-hand side, do I get 1/4 x squared plus 4?
No.
I hope to God not. There's going to be always more when we do that kind of binomial expansion. You can do it. How to get that other stuff?
2 times.
I could write this out twice and go half times half is 1/4 x squared. 2 times 2 is 4, just like I had there, but also 2 times a half x is x, and 2 times a half x is x, so there also needs to be a 2x here, which I don't want to leave out. If you want to do that with Mr. Pascal, by all means, this is a binomial expansion. You could say, well, really, that's just 1, 2, 1 for Pascal's triangle. First thing squared is 1/4 x squared. Walk it down. Last thing squared is 4, or you could put 2 squared. Walk it up, and you'll get the same answer. This is 1/4 x squared plus, so we got lots of 2's here, 4 times a half, 2. There we go. I don't care how you do these problems, as long as you're alert and don't miss the cross terms, or that 2x in this case, okay? All right, so this time we've been solving our radical. We have a parabola. How do we solve parabolas? To factor, we could use quadratic formula. We're hoping we don't have to use the quadratic formula because nobody likes the quadratic formula. Well, I don't know, some people. I'm not a big fan. I try to avoid it. So I need to set stuff to 0, right? I like positive x squared, so I'm going to go this way. This morning they chose to go the other way, which worked, but it was longer. So I'm going to go like this. So I get 1/4 x squared, 2 minus 3 is -1, 4 minus 12 is -8. Oh man, am I gonna have to use the quadratic formula? That's not gonna factor nice with the stupid 1/4 right there. Maybe I should multiply it by 4 and see if that helps. Good choice, Olafina. I don't know if it's gonna help. I might have given you one that has the quadratic formula in it. I think there might be 1 or 2, so be alert. That cancels there though. Minus 4x, minus 32. Oh, that's still 0. Does this factor?
Yeah.
It does, doesn't it? What's factor to, Lindsay?
Oh, we just had 8.
8 and 4?
-8, +4.
-8, +4. Nice. So we get two answers here. X equals, from this one, what makes this factor 0 that makes everything 0? -4. What do I put here to make that 0, which makes everything 0? 8. Two answers. Be skeptical. I mean, there could be no answer to some of these problems. There could be 2 to some of these problems. Usually it's 1, though. Why? Let's go to the graph. So I'm going to forget all of this stuff that I did to solve it. Just leave my candidate answers there. All the way back to the original. And think about the graphs. Good practice for graphs as well. This is a line. What's its y-intercept? Okay. What's its slope?
Up 1 over 2.
1 over 2, so like that. This is the new function we've just been practicing today, graphing, right? Transformation-wise, what's happening? Remember, don't look at this, just look at that.
Plus by W.
What am I doing?
X times 4 + 4.
I'm factoring it, because you got to see it's not left 12, it's left by 4. And then that 3 is some kind of stretch or compression. I'm not going to worry about that for this purpose, okay? So left by 4, 1, 2, 3. Ooh, this is looking interesting. I'm going to see where this y-intercept is just because it's getting close. You guys see what I mean?
Yeah.
So if this is up 1 over 2, back this way it'd be like down 1 over 2, right? Down 1 over 2. Where's the y-intercept for the x-intercept for the line? I think it's at -4, which is coincidental because this time our radical function is left by 4, so it's square root launchpad shape, left 4, and some kind of stretch or something. I don't know. Doesn't actually ever go down, so maybe a little bit better about that. There we go, that's better. Don't want to get too excited here. So, do you guys think these are both answers this time or not? Just barely. This one barely hit the edge. You can even see it, right? I just solved it graphically. There's the solution to that system of equations. Do you think 8 might be the other answer? Could this be at 8? Yeah, I mean, it clearly crosses somewhere else. That place must be 8. But if you have a radical shape, the launch pad shape, in a line, most of the time the line's either not going to touch it at all. You'll get 0 answers for things like this, right? Only if it's just right kind of thing are you going to get 2 answers. And a lot of the time you're going to get 1 answer too, because you could have like this, or this, or this, or this, or this, or that, you know, there's a lot of 1 answer solutions as well. So think about these graphically. Then you won't have to check yours all the time. You can just be kind of trying to look out for those extraneous solutions. Let's look at one application before we quit today. This is just one I found on the internet. So this was like sewage, or I don't think they mean like poo. I think they mean like, you know, factory stuff, pollutants. Yeah, so I don't know. Anyway, discharge that a factory is releasing into a river, probably not good. They say that the amount of discharge in tons per month can be modeled by this function. X is in number of years since 2000. So they say in what year were there about 610 tons coming out per month this factory was releasing into the environment. So where should I put that 610? What is this? Is it an X or a Y value, or is it something else? It's a Y value, I think. This is a Y. So I'm going to put it in right there, and then I'm just going to solve. I mean, that's as easy as most of your problems are. There might be a couple where you need to think about them, so I'd really suggest, as I said, you need to watch that video of mine. It'll be called number 3. It has the relativity example. It's also got some good science that you need. But for us, I mean, we're just solving for X at this point, right? This should be easy. So what should I do?
Or no, divide.
Go back to the 3-step process. Isolate,
Divide by 2.
Square or cube or whatever, power it,
And then
and finish.
divide by 2 then.
I think it'd be better. Now, you can still get away with solving this if you square it first, but then you're going to have to square 235 in. I don't want that big of a number in here. I don't think you do either. Is that reduced nice or not? I don't know.
No, not really.
What is it?
2.595.
Okay, let's hit math fraction and have your calculator reduce it to the simplest components. For instance, 5 goes into both of these, I know. Let's reduce it and leave it as a fraction.
122 over 47.
Over 37?
47.
47. That's from 5. Doesn't 5 go in probably 122 times? I bet that's it. So that's as simple as the fraction gets. I'm going to leave it as a fraction because I don't want more error in my results than I have to have. And if you round a decimal, you've got more error that's sneaking in at that point, right? So let's square it now. Instead of trying to square a decimal, we're just going to square this top and bottom. So I guess we're going to get some big numbers no matter what here. What is 47 squared? I do not know my squares that high.
2,209.
And the top is way big, right?
14,884.
Okay, cool. So remember, keep your eye on the prize. You're trying to get X. Next step?
Subtract.
Subtract. So I'm just going to go like this, okay? I'm going to say negative 0.75 plus or minus this? Plus this. The last step is
Divide by 2.
divide by 2. And you'll get X is that stuff, which you can have your calculator do for you, and you won't lose any precision. What is it?
2.994.
Can you guys confirm, Anna? This is a place our calculator could lead us astray. Let's confirm her. Let's get some confirmation on that 2.994. Not that I don't trust Anna's magnificent calculator skills.
That's what I got.
Yeah? Yeah? Okay. Cool. So the key here is also interpret your answer. Like 2.994 what? What were we trying to answer in the first place?
Tons of
In what year? See, in science, you should be starting to get trained like this. Before we even sort of started this, we should have said, what are we trying to find here? I'm trying to find what year. So I'm trying to find X in this case, because that's the question, right? So X in this case is 2.994 years, but that actually means 2003. So this is like, so this plant outputs 610 tons per month of wastewater in about 2003. If you guys want to go to college, if you guys want to take advanced classes, the math in those classes often will be easy. If you learn what you're supposed to in here, it's not going to be difficult. The thinking, the conceptualizing is what becomes more difficult. And that's what you're practicing here if you're actually practicing authentically. So this is what and where it's really at. Focusing on that interpretation. What did I just do? Not like where did I throw this into the equation and I pump out my answer, but what's it mean? What was I actually doing in the first place? I'll see you next time.